All right, welcome to this new section called Amazon VPC. The expansion for VPC is Virtual Private Cloud. Now, looking at this diagram, you might have guessed what VPC is. It resembles our traditional network that we operate in our data center. In other words, VPC is what is used to create network in the cloud. Now, everything that we can do in our local network can be done in Amazon cloud network called the VPC. But it has a benefit of it being scalable. Now VPC has these will go on correction. The VPC, it looks simple from the outward, but there are a lot of things going on into it, like the subnets, like routing tables, internet gateways, DHCP providing dynamic IP addresses. If I don't want dynamic IP addresses, I can go for elastic network interface card. If I don't want, if I need two NIC cards, then I can go for elastic network interface card. And then we'll also be talking about endpoints, how I can make my VPC connect with a bunch of other services in Amazon. So let's go over them one by one in the coming sections. Let's talk about VPC subnets. VPC subnet is a range of IP address in our VPC. Now I can launch instances, or I can launch computers, I can launch database computers, and I have the option of picking which subnet do I want to launch my EC2 computer, or when I say EC2 computer, it's VM I'm referring to, VM for web server or VM for database server. Alright, so that's subnet. Now let me quickly show you how things look like in the console. I believe giving you a good visual helps you understand these concepts a lot better. Alright, let me open up my console and log into it. And once I'm logged in, look for VPC. Let me click on your VPC or my VPC, and these are the VPCs I have in my account. Now VPCs are region specific. We'll talk about them a little later. VPCs are region specific, and I can have multiple VPCs in my account. Alright, but our real focus is on the subnets. So let's focus on subnets. Look at this. I have a VPC. This is my IP range that I have chosen, which means that any server that I launch within that VPC will pick that particular IP address. Now if I'm picking this VPC, or if I'm launching any server or service in this VPC, it's going to pick an IP address in the range 172.31, and you probably might be able to guess for the other two. If I'm picking this, the IP address is going to start from 10 dot series, and if I'm picking this range, the IP address is going to start from 192.168 series. But still, that's not what we want to talk about more at the moment. We would like to talk about subnets. All right, now look at this. Subnets are smaller section of that bigger section. What do you mean by that? Look at this VPC. This VPC has a bigger IP range, 172.31.0.0/16. Now I can take this bigger value and sort of split them into small values, right? Assume that if this can launch like 4,000 computers, I can take them and sort of section them into 2,000 computers here and 2,000 computers here. That's called subnet. All right. So what's subnet again? Subnet is a range of IP address in your VPC, and we can launch AWS resources into a specific subnet. Subnets can be of two types, depending on how we configure them. They can be public facing subnet. They can be private subnet as well. Now look at this. If I'm putting my web servers in this subnet, obviously web servers need to be internet facing. They become a public subnet or internet facing subnet. And if I'm putting database servers or app servers in this subnet, then they will have to be hidden from the network, they will have to be hidden from the internet, so they become private subnets, meaning not reachable from the internet. So what's VPC and what's a subnet? VPC is the full environment, and subnet is sections in that full environment. Alright, so let me show you how to create a VPC, and we look at all the subcomponents that go in a VPC. So let me create a VPC called Gray Campus. Right, and let me also pick an IP address range for it. That would be /16 create. Now what I have done at the moment is I have created. Let me change the color of my pen and also the appropriate brush. Right, there you go. So what I have done is I have created the bigger environment. Alright, and I've given it an IP 10.0.0.0/16. Alright. Now this is the VPC subnet or the VPC range. Now in this I can sort of section them, and I can have 2 or 3 subnets, right? I can have 10.0.1.0, 10.0.2.0, 10.0.3.0 /24 /24 /24. I can have that, and like I said, this could be private, this could be public, or private public, vice versa. This could be public at the same time. So this is a good use case for web servers, this is a good use case for web servers or mail servers, right? This is a good use case for DB servers because this is in a private subnet. Alright, so let's create a subnet now. So let's pick the appropriate VPC that we want our subnets to go on. We can name it public subnet. Let's start with private, right? So let's create a private subnet. What was the range? It was 10.0.0/1, excuse me, 10.0.1.0/24. Let me go back and look at what we have. It was 10.0.1.0/24. The other one was 2, the other one was 3. Right, it says it's not a valid block because we did not put it correctly. Alright, so this is a private subnet. So what are we doing? We are taking a bigger environment and we are creating small chunk environments in that. So let's create another subnet called public 1 subnet. Alright, let's put that in a different availability zone. Just being a bit lazy here, so let me copy and paste that. There we go. Let's create another one. So this is public 2 subnet. Right. 24. This is 2 as per what we have in the diagram. Can we not use it? Right, as per the diagram it has to be 3. Right, there you go. So we have 3 subnets in our VPC, and I want you to look at this. Look at this. Now this is spanning 3 availability zones. All right, a VPC can span a full region. In other words, look at this. The VPC can span a full region. This is AZ1, or maybe we can look at this diagram. Right, the VPC is spanning, this VPC is spanning multiple availability zones, but the subnets, they sort of stay within the availability zone. So that's why we created 3 subnets and we put them in 3 different availability zones. Now we can create 3 subnets and put them in the same availability zone if you wish, if that's what you want. But what I'm saying is subnets, they stay within the availability zone, but VPC, they span availability zone. All right, let's talk about route tables. Now route tables are right. Let's talk about route tables. Route tables are a set of rules. They're called routes, and they determine where the network traffic is directed. Let's see. Right, now look at this. This VPC has an router in it and also has a route table in it. So this route table sort of tells the whole environment that if you want to reach the internet, now this IP address refers to internet 0.0.0/0. If you want to reach the internet, contact internet gateway. If you want to reach another service in the VPC or another IP address within the VPC, it tells that machine it's very local. You don't need another device to reach it. You can talk to the instance directly. But on the other hand, if you want to reach to a server in the internet, use internet gateway like this. Use internet gateway, and that would take you to a route to reach that particular server in the internet. All right. So what's route table again? Route table are a set of rules called routes that determine where network traffic is directed. And route tables, they help different subnets within the Amazon VPC to communicate with each other. And these subnets can be pointed to multiple exits. For example, in this case, we had an internet gateway here. So this route table is pointing to an internet gateway. Assume that I have an office environment here, my local DC, all right, local DC, and it has an IP range of, let's say, 10.0.0.0/16, let's say, all right, and I would have a VPN connection. All right. Now I can have another entry in my route table saying that if you want to reach this 10.0 network, now send it through the VPN. So in other words, we would have an entry in the route table. I can do a quick erase here so we get some space. All right. So I can have another entry here in the route table that says if you want to reach 10.0.0.0/16, use VPN. All right, so that way anytime the server wants to talk to a server in the local data center, it checks the route table and it uses the VPN connection to reach the local data center. So I believe you get a fair understanding of what route table is. All right, next is internet gateway. From the previous slide, you might have a few understanding on what internet gateway is. And if you're thinking internet gateway lets you go out and reach the internet, you are absolutely correct. Internet gateway helps in communicating helps the instance to communicate with the internet or services or servers in the internet. Now, as we saw in the route table, The route table contains two routes. The local route, maybe I can show it to you again. Right. The route table had two routes. One is a local route that's permitting inter VPN connectivity. That's right here. See, it says local. Right. The other one was to let go and reach to the internet. So let's do one thing. Let's create an internet gateway. And it's right here. Let's create an internet gateway and call it Gray Campus Internet Gateway. Alright, an internet gateway is created. Now this internet gateway needs to be attached to our VPC. So let's attach it to our VPC called Gray Campus and attach it. Pretty much done. Alright, now let's work on route table a bit. Let's create a route table in our Gray Campus VPC and let's call it the public route table. Right, now look at this. It already has an entry for the local network. Now we said this is a public route table, so this has to have another route entry that's pointing to the internet gateway. And we know that if a service needs to reach internet, the route entry we would want to give is 0.0.0.0/0 and click save. And from our other example, if we have a VPN connection, assuming my local environment's subnet is 192.168.0.0/16, let's say that's my local environment's IP subnet range, I would give that IP address here and then give the VPN gateway as the target. Now we don't have a VPN created yet. We'll be doing it in the coming sections. So you get the idea, right? What subnets are and what route table is and how route table is defined or how route table helps achieve the subnets to reach locally, to reach internet, and also to reach the local data center. The next topic we will want to discuss is dynamic host configuration protocol option set. Now, we should be familiar with DHCP in our environment. When you go to office and connect your laptop to Wi-Fi and connect your laptop to the Ethernet cable, once you turn it on, you get an IP address automatically, right? That is done by a service called, or a server that's running the service called dynamic host configuration protocol. Now, even in VPC, we can have the same type of setup where I spin up a machine and it receives an IP address from a server directly. All right. So dynamic host configuration protocol, it provides a standard for passing configuration information like the IP address and domain name to computers in a network. Now we can use an Amazon DHCP, or I can create an custom DHCP. If I want to have an custom DHCP server in the environment, that's possible as well. All right, but I can't have both. I can either have the one that's created by Amazon, or I can create my own DHCP environment in the cloud. Now let's see how that's done. Now look at this. At the moment, this is using Amazon's DHCP service. This is a shared server that we are using. But if I want to create, assume that in my environment I have a DHCP server running. If I want to create a DHCP, or if I want to use that DHCP server in my environment, I can create an new option set and have it attached, right, and have it attached to my VPC. That's possible as well. All right, the problem with dynamic, let me talk about the advantage first. The advantage of dynamic host configuration protocol is that it takes away the administrator's burden of assigning IP address to each and every machine individually. All right. On the flip side, the disadvantage is the IP address changes. If I did not turn on my machine for 3 or 4 days, let's say, the IP address would go away. And let's say if another application is using that IP address to connect to my machine or to the application that's running in my machine, it's going to be a problem, because now the IP address changed. I'll have to call the other person and update them with the new IP. All right, that should be okay if that's just one application that's trying to connect to my EC2 instance. If it were 1,000 applications connecting to my EC2 instance or a server, let's say, it becomes a problem. So for that purpose, I would want to pick an IP address which is sort of static, which never changes. It's sort of static to my environment. Right? I can leave the system not running for 10 days or so, but still the IP address is not going to change. I can come back, turn on my machine, I get the same IP. The applications, the 1,000 or the 10,000 applications that were connecting to my EC2 instance, they're going to work just fine because the IP address hasn't changed. That functionality is given by elastic IP address. Right. So it's like this. Assume that I have an EC2 instance running. All right. Now this is going to have an DHCP IP like 192.168.1.20, let's say. And after, let's say I turned off my machine, and after a week, if I turn on my machine, it's going to have a new DHCP IP. And that probably would be 192.168.1.100 maybe. Now all the applications that were connecting, all right, assume they're applications, different applications. Look at this. This looks like a square. This is a circle. So different applications trying to connect to my EC2 instance. Now they're all going to fail because the IP address has changed. It's a new IP address. I'll have to call all of them and update the IP address. But if it's a static IP that I've assigned to my EC2 instance, they're not going to change after a week or after a month. You know, if I turn off and turn on the machine after a week or after a month, the IP address is still going to be the same. 1.20. And all the applications are still going to connect without any issues, right? So that is a procedure we will have to follow to assign an elastic IP address. That's right here. So click on elastic IP, allocate a new address for yourself, right? So this IP address is not going to change. I can associate this address to, I don't have an instance running at the moment, but I can associate this IP address to an EC2 instance, and anytime I stop and after 3 weeks or after a month, if I start the instance, the IP address is going to be there for me. the applications are going to work just fine. All right, let's talk about network interface card. Now we're still talking about the components that are available in a VPC. Now at a later point we are going to connect all these components together and create a full-blown VPC. All right, so a network interface card is also a component in the VPC. Look at this, it says it's an elastic network interface card, which means I can have a computer, I can have a range of network interface cards. They're sort of separate, you know, they are separate entity. They're sort of separate, and I can have multiple network interface cards. This can be NIC 1, this can be NIC 2, this can be NIC 3, this can be NIC 4, stuff like that. The way or the place this will become handy is, let's say I just have one server and I would like to run 4 web sites from it, and I want to have some sort of separation between them, IP level separation between them. Then I can go for 3 or 4 network interface card assigned to an EC2 instance. All right, and then point website 1, it's going to have 4 different websites, and point website 1 to the first NIC, point website 2 to the second NIC, or point NIC 3 to the third website, and point NIC 4 to the fourth website. That way, users or application accessing this particular IP address will be directed to the first website. Users accessing the second IP will be directed to the second website, and whoever accessing the third and fourth IP will be directed to the third and fourth IP as well. So that's how it's going to work, and that's the use case of a network interface card. Let's talk about endpoints. Now, endpoints are services that helps us connect with other Amazon services. Now, Amazon has a bunch of products that are not, they don't come in a VPC. For example, S3 is a service outside of VPC. All right. Anytime we want to access S3, let's say, all right, look at this. Anytime if I want to access S3, all right, it's going through the internet gateway and it's reaching S3, right? Now, if I want to have a private connection between my VPC and S3, and to avoid going through the internet gateway, I can go for endpoint or private connection. The way I would do it in the console is, again, go back to VPC, endpoint service, create an endpoint, and which VPC was that? Sorry, it's endpoint, create an endpoint. Right, I'm looking for S3 service. Let's switch to our VPC. Right, our VPC had 3 subnets. Pretty much create an endpoint. And once it gets created, I will have to map it in the routing table. I'll have to go back and map it in the routing table like this. Now it's going to take some time to reflect. We might need to wait. All right, look at this. This is how the entry is going to look like. So anytime the service, in this case, it's S3, anytime the resources in VPC, when they want to communicate or when they want to contact a service in S3, now that we have added an right, now that we have added an endpoint here, now the connection is going to go through the endpoint exit directly and not through the internet gateway. So in other words, it's going to look like this. It's going to look like this. See, now connection to S3 is going through VPC endpoint and not through the internet gateway, and there is an entry for the VPC endpoint. All right. So what are we achieving by this endpoint? With endpoint, we are achieving better latency. All right. We are prioritizing traffic. Not all traffic is going through the internet gateway. Some traffic are prioritized and they are sent through VPC endpoint. This gives us better latency. All right, now that we looked at the different components in a VPC, Let's also spend some time understanding different types of VPC one can create. One size or one type of solution won't fit everybody. Some companies have a certain set of requirements, some other companies have a different set of requirement. The environment is different. Connections coming from the internet might be huge for some companies, and connection from local data center might be huge for some companies. So there are 4 basic types of VPNs that we can create. Now look at this first one. This one is a single public subnet. This is a good use case if we want to put all we have is just web servers. All we have is just web servers. This is a very good use case. I can have a VPC with a single public subnet, put all my web servers, configure internet gateway and direct the traffic to the internet gateway. That's it, I'm done. My web server is ready and they can be connected from the internet and they can connect to the internet. So this is type 1. The other type is a bit more complicated, I would say, or a bit more customized, I would say. Now look at this. We are introducing an database server and a private subnet here. Now if my environment is an medium or a big size environment where I maintain a separate data farm or a data tier, then I would need a VPC with 2 subnets, one public subnet and one private subnet, and database, they reside here and they get connected to the internet through the NAT gateway. Now look at the routing table here again. We have an route to the internet, and for the database they get connected to the NAT gateway and they get internet access. Now what's the difference between the first type and the second type? Here we have 2 subnets. We have introduced an database layer in it, or the database tier in it. We're having 2 routing tables, one for the public subnet and one for the private subnet, and we have also introduced an NAT gateway in this environment. Now we're going to talk about NAT gateway in a coming section, so don't worry about it for the moment. The third type is, look at this, it not only has a public environment, it not only has a private environment, but it also has an corporate environment, meaning there is a new connection, or the VPC is now part of the corporate environment. Now this is called as an hybrid environment also, where the servers in the company or the servers in the corporate, they can connect with the servers in the VPC using the VPN connection, and vice versa. Servers in the VPC, they can get connected to the computers or servers or applications in the corporate network using the VPN connection. So we see how we are sort of building a VPC from a basic single public subnet VPC to a public and a private subnet VPC to an VPC with public, private and an hybrid VPC where I also have connectivity to my corporate network using an VPN connection. The fourth type, or the fourth common type of VPC, is a VPC with a private subnet only and a VPC with an managed VPN access only. Now this VPC do not have an internet gateway. This VPC cannot be accessed from the internet, and servers in the VPC cannot go online or cannot reach the server in the internet directly. Now the use case for these type of VPCs would be, if assume that I've been asked to provision 10 more servers and I don't have enough space in my data center for 10 more servers, so I can quickly launch an VPC, put those 10 servers in it, create a VPN connection between them, select the IP range which matches my local environment, and boom, my 10 or 20 servers that I wanted to launch is ready. and the users are not going to find any difference. For them the server would be local because there is a VPN that is connecting both the data centers, Amazon and the cloud, Amazon and the local data center. The IP address is the same, so the users or the applications, they won't feel any difference where the server is. So this is another use case where we would bring in VPC with the private subnet only and managed access VPN. Alright, now you might have some questions about, we spoke about NAT gateway. What was that? We spoke about private networks. There were a couple of other things that I saw on the picture, like VPG, CGW. What was that? Stuff like that. So we're going to get those things sorted out. We're going to learn about NAT instance, NAT gateway, VPN, virtual private gateway, customer gateway in the coming section. Let's talk about NAT instance first. Now, NAT instance is a service that helps you reach the internet. Other words, now look at this. This is an environment where we have a NAT instance. Now, NAT instance is like a proxy, right? Now look at this. Anytime the web server wants to go online, it connects to the internet gateway, right? Anytime the private subnet database server wants to go online, it can't go directly to the internet gateway, but it has to go to the NAT instance, right? NAT instance is like a proxy device. NAT instance is like a proxy device that receives traffic from the database, and then it creates a connection to the internet and receives the return traffic from the internet. Let's apply return traffic from the internet and give that information over to the database. Now, what are we achieving by this? We said NAT is a proxy. All right, proxies are helpful to hide the servers behind it. For the internet user, for them, they are only connecting to the proxy, and for the database, they are only connecting to the proxy. So there are two separate connections. Databases are completely hidden from the external world. An external user at any point won't be able to connect to the database directly if we have an NAT instance in between. Alright, the previous slide was about NAT instance. Let's talk about NAT gateway. Now, both does the same thing. Both provide proxy servers, both hide the servers behind it from the internet. So what's the difference? Well, it's just the name. That's called NAT instance and this is called NAT gateway. Now, why is that difference? Now, NAT instance is an EC2 computer or an EC2 VM or an EC2 instance that's running that service, whereas NAT gateway is a managed service by Amazon where we don't get to manage. Amazon manages it for us and we only get to use it as a service. On the other hand, NAT instance is a server that we will have to launch and we will have to do some configurations in it, update few settings in it and make it work. On the other hand, NAT gateway is an service by Amazon. So how can I provision a NAT instance and how can I provision a NAT gateway? Now I'm only going to show you how to create a NAT instance and how to create a NAT gateway. We're not going to connect it yet. Connecting all of them together will be covered in the lab section. All right, we said NAT instance is an EC2 instance, right? So I'm in the EC2 console under services, under EC2. I'm trying to launch an instance, and here I'm going to go to community AMI and look for NAT. Right, so this is a server, this is an operating system that has pre-installed NAT software in it, so I can use that. Which VPC is it? There you go. The campus. Which subnet is it? Public. Alright. Let me make it as simple as possible by keeping all the defaults, or keeping it with the defaults. Look at this, it's an instance that's getting created, and that instance that's getting created. Now I'll have to update my routing table to point the connection to this instance, and the instance would filter the connection. It would act as a proxy. It's going to make connection on my behalf, and it's going to get that information back to me. Right. With NAT instance, there is one more setting that we will have to do in addition to launching an instance. That would be under networking. That would be change source destination check. Right, so now that this has launched, let me go to VPC. And update the routing table. Right, here is our VPC. There you go. There you go. Let me create a new routing table for the private. Routing table. On the private routing table, now if I want to go online, look at this, it's internet gateway. Now this is my NAT instance, so if I want to go online, I would point my connection to the NAT instance. All right, so the database server, anytime it wants to make a connection, it would send the connection to the NAT instance, and NAT instance would make connection on behalf of it. On the other hand is NAT gateways. Now NAT gateways are managed service. I don't have to create an EC2 service. I don't have to create an AMI. I don't have to add storage to it, stuff like that. This is a managed service where everything is taken care of by Amazon. In a bunch of clicks, you're gonna see, and give it an elastic IP. It's in a bunch of clicks. My NAT gateway is going to be ready. And the difference between managed servers and customer managed service is that if that NAT instance, the EC2 instance that we saw sometime back, if that goes down, it becomes my responsibility to bring it back again. Let's say if it goes down at 2 in the night, I will have to have my team member wake up, or I myself will have to do it, wake up and reprovision that server. But if it is a managed service, Amazon manages everything. If this goes down at 1 or 2 in the night, Amazon would reprovision it automatically and would just send me an email or an alert saying that it went down but was reprovisioned in less than a minute or less than 30 seconds maybe. Now this is going to take some time to get created. And all of these uses SDN technology behind the scenes, virtualization and SDN technology behind the scenes. Now once this becomes available, I should be able to go back to my routing table and be able to edit it in the routing table. There you go, there's my NAT gateway. So again, I won't be using both NAT instance and NAT gateway in an environment. I would use any one of them. So I cleared that up. So in this case, if I want to send my connection to my NAT gateway, then I would point it to the NAT gateway like you're seeing it right here. Point it to the NAT gateway, click save. So the connections are going to go to the NAT gateway now. So they're going to go to the NAT gateway now and get connected to the internet. Now look at this. All public subnet go to internet gateway, all private subnet go to NAT gateway.